Good afternoon. This is a session about AI machine learning in IT, SRE, DevOps, and the innovations there that is fundamentally going to change the way the IT teams, SRE, DevOps teams potentially serve the businesses in the context of hybrid multi-cloud workloads that are getting deployed. So next couple of slides will talk about the challenges the IT environments are facing today and the approach that one could do to take to absolutely be the application business service first, and followed by a small demo of what this looks in action. So to introduce myself, my name is Varma. I am representing HPE OpsRamp. We are recently acquired by HPE as an observability, hybrid observability platform for global enterprises to consume. The agenda for today is the drivers in AI, machine learning, and IT ops, challenges faced by ops persona. The world of ops now consists of IT, SRE, DevOps, and developers playing a major role in instrumenting the applications with the signals that are needed for application availability. How this vast amounts of data is changing the landscape of observability and AI machine learning techniques to really find that probable root cause, and a demo. And if time permits, we will keep a few minutes at the end for questions. Let's start with the primary drivers that is causing this AI need in IT operations. The first order of priority is the explosion of observability data, right? If you look at the data that used to be the primary source for finding the probable root cause, used to be just the metrics alone in the good old days. Now it is a combination of cloud workloads spitting out metrics, logs, and traces, and the infrastructure that is federated between on-prem, and cloud combination. And then ops persona, if you look at an enterprise, the IT ops and SRE DevOps are three different pieces of the puzzle before, but they're all converging now. And what that is driving is, instead of being reactive, to be a proactive and a predictive, and to kind of make that happen, AI machine learning is the only way that you could potentially drive that predictability and proactiveness. And the convergence of this operations persona and the large amounts of data that needs to be processed to deliver the outcome, that is what we call future ops. And the future ops is not future, it is here, today. And every enterprise, their workloads are multi-cloud, if not single cloud, and it is not just cloud alone, there is hybrid. And we'll talk through that. So the data explosion, let's take a look at that, right? At the bottom of the stack is the new infrastructure. It consists of workloads that are still in the data centers with VMware, maybe some financial applications still leveraging those mainframes in the data centers, while new workloads are going into the cloud. And then the edge participating in a major way, right? Edge is now also changing. If you look at the edge, gone are the days of MPLS circuits serving the branch office of a financial institution or a retail location of a warehouse or a retail location of a grocery store. So they're all now SD-WAN, SASE, new infrastructures are coming to kind of optimize the edge. Now, on top of this infrastructure stack is the applications, the traditional application workloads that are still running in the enterprise, combined with the cloud native workloads that are coming on top of multi-cloud environments, and the edge optimized workloads where the applications that are serving on the edge are now intelligent to really give an end user performance based on new age edge infrastructures. This is what in HPE world we call edge to cloud. Now let's look at the ops data that is coming from this edge to cloud. On the left-hand side, when you have hybrid infrastructures with on-prem data centers, there is multi-vendor infrastructure elements. You have traditional IT, compute, storage, network suppliers, the big vendors that are supporting on the on-prem infrastructure, for a long time. And those infrastructures are there in every enterprise today. And that is ingesting a lot of signals and observability data that is coming from traditional monitoring systems and things like that. Then the cloud is giving its own cloud native observability data in the form of logs, traces, and metrics. And then on the right end, which is on the edge infrastructure, it is also multi-vendor and a lot of disruption on the edge infrastructure with 5G participating in a big way, and edge, in some of the edge locations, new age networking technologies are getting deployed to kind of give that app compute network oriented infrastructure that is sitting on the edge today to deliver what the end edge location needs from a business operations point of view from the central IT. If you look at that, and then there are additional signals that you are ingesting from real-time user monitoring, synthetics, and a lot of other signals that you are going to give to really make sure that the business at the end customer's location is delivering what it needs to deliver from an end user perspective. That's the explosion of data. Now, let's take a look at challenges facing the ops persona. When everything is run by humans and without any AI machine learning playing into the role, right? In the traditional world, we're detecting the issues by measuring it. Traditional infrastructure monitoring in the form of templates that applied to those edge and on-prem data centers, monitoring templates with thresholds and things like that are applied. You probably have them still in those locations. That is giving a lot of detection of those issues, and then investigate and analyze, and then potentially remediate and operations. This is a cycle that has been going on for a long time in IT environments. Now, if you take a look at that, there are three pieces of things that is taking place. One, vast amounts of observability data, and that data is now a combination of monitoring data, observability, extending to the application stack, all the way to the end user's performance, that is giving a lot of complex sources of data that is getting ingested for doing what IT needs to deliver. And now this data is coming from multiple locations, cloud, multi-vendor, multi-cloud, and all of this data needs to be processed to kind of really deliver what a human needs to deliver from an IT operations perspective. When enterprises have these silos, the first incarnation of AI machine learning took place with just alert correlation. You see a number of companies using the word AIOps, right? The first implementations of AIOps is primarily to do alert correlation. Throw me all the signals, I'll somehow figure out what the needle in the haystack is to reduce the level 1 talent that is needed with eyes on the glass to determine where the problem is. That works if all you are looking for is just alerts and reducing the level 1 talent that is needed for processing those signals to determine who in level 2 or level 3 engineer needs to be elected and things like that. That doesn't solve the problem of having 100 people on a conference call when there is an outage. That is the complexity that human operations really took place with the ingestion of volumes of data, and the focus is more on the alert correlation piece. And that fundamentally has human misses, human errors, and more importantly, a lot of stress when there is an outage. Make sense? Now, let's go take a look at what this observability assisted by AI machine learning will look like. Everyone is using a copilot, right? You have backup copilot, you have office copilot. Let's imagine that you apply the concept of copilot to business services and application services that IT, SRE, DevOps needs to deliver to the end customers. It starts with vast amounts of observability data, complex set of resources that needs to be done, and that needs to be applied to multi-vendor, multi-cloud. And to do that, if you imagine that there is operations teams that are delivering based on human, but with AI machine learning, you introduce the concept of a copilot to assist the entire end-to-end chain from edge to cloud. Again, the infrastructure is from edge to cloud because cloud is delivering application, but that needs to be consumed by edge. And that is the biggest piece of the puzzle. Being able to deliver that business service to the edge is what really makes this complexity of sources of data to be ingested to determine what is taking place underneath. And let's go take a look at the functional pipeline behind this edge to cloud infrastructure that needs to be delivered in a form of a fashion that matches the end user's expectation. The fundamental problem still remains the same. Detecting the issue, investigate and analyze, but remediate and optimize. To do that, if you take a look at the functional pipeline that is underneath, the functional pipeline looks different now. If you look at edge to cloud holistically, the pipeline starts with, on the left extreme, discovery and observability in a holistic manner. And it needs to be adaptive. The reason for that to be adaptive is, as you know, the modern workloads are coming with DevOps pipelines automating end-to-end. The new pipeline with cloud native infrastructures coming in an agile, nimble manner. And there is no time for someone to go humanly intervene to kind of do the instrumentation that needs to be done for those workloads. That starts with whether you take open telemetry in the cloud native workloads or in the on-prem workloads, the traditional infrastructure elements that needs to be instrumented to really discover. If you don't discover the entire estate from edge to cloud and really look at that holistically, I think more and more silos gets created. If I speak to any CIO, a lot of large enterprise CIOs, their number one complexity is more and more silos getting created as the workloads are getting spun up in the clouds because the traditional edge and on-prem infrastructure is not completely evaporated. They need to be consumed. So the pipeline starts with being able to discover and observe everything that is there on the environment. Then intelligent alerting, not after alert comes out. How do you make sure the source of alerting is based on dynamic thresholding, based on really AI machine learning assisted thresholds that purely determine when the alert needs to be generated. And that is super critical as the complexity of data source increases. once the alert comes, how do you kind of correlate these alerts? Not by just text signals and text parsing, but understanding the topology, the infrastructure topology that is supporting that application or that business service. It is the topology that ultimately gives the source of truth when an alert comes, right? That's what we mean by a correlation that is assisted with topology in the thing that ultimately results in finding a probable root cause. And once you find the probable root cause, can we remediate? Can we do an intelligent escalation on it? What we mean by that is, if there are actions that allows that remediation to take place without a human in the loop, can this copilot with AI machine learning remediate, self-remediate it, or extend the performance that is needed because it knows there is certain capacity that needs to be provisioned? Case in example, a Thanksgiving weekend with a Black Friday shopping season, there is new infrastructure that needs to be, the e-commerce retailers needs to provision new infrastructure to kind of really make that happen. Can that take place in a AI machine learning assisted manner? And then also determine when the scheduled maintenance needs to be done. How does it take place? Because if you look at the need for patching, the need for maintaining the preventive care that needs to be done on these underneath infrastructure elements is not going to go away. Whether it is Kubernetes containers that are running on a VM or natively on a hardware, still there is maintenance that needs to be done on those things. But last but not the least piece is, how do we drive automation with a process-driven approach? So if you look at this is what we call a discovery to resolution pipeline. Discovery from edge all the way to the cloud, instrumenting with observability, and processing the alerts and signals, and making sure that the source of those signals are clearly understood to find the probable root cause, and then automating whatever can be automated. That's what we call the discovery to resolution pipeline, and that pipeline plays a major role in delivering business services to end users wherever they are in the world. And now, let's go take a look at when we do this outcomes that comes out of this thing. Number one, the outcome is moving from preventive to proactive, right? Basically, instead of reacting, how do we kind of become proactive, and how do we kind of predict things that before they happen? That's number one outcome. Number two is, can we reduce the number of human actions that are required for finding a cause and remediating a cause and making sure the end business service is delivered in a meaningful way? That's number two, reducing the human operations. Number three, improving the business service health for the end customers. And last but not the least, optimizing the cost and making sure the cost modeling is taken into consideration. That is what we consider end-to-end discovery to resolution in a unified way. And the unification and simplification is the most important parameter, because without that, more and more silos gets created. To show this in action, I would like to invite my colleague, Radhakrishna Kukunuri, to come and give a quick demo of what this looks in action.
Thanks.
Thank you.
Thanks, Varma. Good afternoon, everyone. So I'll quickly walk through, what Varma outlined in terms of AI and ML pipeline and how, it actually optimizes, the IT operations delivery. To go further, I would start with how the industry is evolving in terms of the AI/ML models, approaches. We have this traditional predictive models in terms of how they analyze the data with some labeled and supervised models to basically understand the relationship among those data points, and comes up with certain intelligent insights from that data. And then we in the recent times we saw the Gen AI models evolving in terms of how they get creative in knowing the patterns without much labeling and a lot of unsupervised learning kind of a thing. And Gen AI models is what we commonly know as the Chat GPTs or OpenAI driven models and all of that. Now, taking that foundation models and really applying the large language models in terms of feeding a lot of data, and there are multiple kinds of data that get fed into that LLM models, in terms of the traditional or regular classification mechanisms to feeding text, image, video processing and things of that sort. Different kinds of data points, as they get fed into these LLM models, we get outcomes in terms of broad applicability of these LLM models to a wide variety of scenarios. And again, we are seeing this in the more common world in terms of the search engines or things of that sort. But taking that foundation models, how do we then optimize it for a special vertical based use cases? This is where a lot of us in the operation space, I think we are taking this approach in terms of taking that trained LLM models and really verticalizing it for a certain use case. And I think obviously in this case, it's about IT operations. Again, as we apply that traditional LLM models in a privately trained fashion on operations data, we could basically drive certain outcomes like, obviously correlation and all of that noise reduction as one immediate use case. That's where the existing environments, the incumbent environments are really struggled. So obviously there is a lot of value and immediate benefits that we see over there. But how do we evolve from there to really drive predictive and even preventive kind of a use cases is how we are looking at it. And obviously feeding a lot of observability signals and training the LLMs based on private LLMs based on this approach is how we see the industry could benefit, the operations team could benefit out of this. Now, to show this in action, I would actually switch to the OpsRamp way of doing things. All of this, what we have seen, we'll see this live in action in terms of how OpsRamp is handling this. And just to quickly intro about a quick overview of OpsRamp, we are a hybrid digital command center where we really want to comprehend all of that discovery to resolution aspects of the operations pipeline into one single platform. So that's where you see starting on the left side of the pie, you see all kinds of signals from data center and cloud environments going into OpsRamp with native abilities of instrumentation. We'll see that, as well as our ability to integrate with any other solutions that may be doing it as well. But as we ingest the data, on the right side of the pie, you see the event management aspects of it, in terms of how we combine all of these data signals and use machine learning to analyze this data to really understand, how some of these data points are related to one another and things of that kind. And finally, bring in automation in order to remediate some of these issues in a time efficient manner and things of that sort. And being able to drive all of these aspects, the so-called discovery to resolution, and driving all of those benefits on the right side is how OpsRamp adds value to a lot of enterprise IT operations that we typically engage. Before I jump to the live demo, I'm again mapping back to the operations pipeline, the functional pipeline that we all desire, in terms of how we bring together all of these things for the new future operations model that, we all wanted to march towards. To start with, we all love AI, and that's where, we are all here trying to understand how, this AI can be applied for efficiency and optimization. But the effectiveness of AI actually starts only when we have quality data. So that's where, it's important that we gather a lot of these observability signals into the platform and into the engine to basically feed into the engine and then let the engine take decisions and all of it. So this is where, we'll first understand how we look at that observability, the quality of observable data being gathered into the engine. So I think what we will see quickly is a video that I wanted to play back. What you'll observe in the video is basically how OpsRamp as a solution talks to all of the edge to cloud assets in understanding what assets exist, how they are connected, and then ingest a lot of signals. Just like we humans, we only believe something through our senses. We want to hear, we want to see, we want to touch, we want to taste, we want to smell, and the same applies for machines, where they need a lot of these different signals to understand the context and really, help towards a decision. So these signals are metrics, the assets metrics, logs, traces, or more of security data and compliance data kind of a thing. And there are more signals that we could add and enhance the models, as we expand this thing. And so what we'll see is a recorded video in terms of how OpsRamp captures all of this observability data and presents in one view, in a unified view. Almost before AI or ML can take action, even in the current state, there is benefit where human operations could derive efficiencies by having data in one place. So this is where. So to start with, you could see OpsRamp basically talks to all of the edge to cloud environments. So you would see servers to network to storage, all compute network storage to any converged virtual, all of that, as well as any multi-cloud environments as you may expand, or your SaaS and PaaS applications that you may be subscribing for, or your cloud native environments. So being able to discover all of these assets, and what I mean by discover is obviously trying to capture a lot of configuration information, but at the same time the relationship between these assets, how they are connected to one another. So this is something that OpsRamp presents in an automated fashion. As we talk to an infrastructure, I'm showing the example of an infrastructure topology here, where OpsRamp presents the connectivity between what it sees on the network and how the network elements are connected to the ESX servers, to the storage, and all of that, right? And then similarly, if we expand this into an application view, and here I have an example where I have few containers running on VMs inside my Amazon EC2 environment. And again, OpsRamp discovers all of that as well in an automated fashion, where it presents, okay, here are the VMs, here are the microservices or containers that I detect on those VMs and all of it. So again, the bottom line is being able to understand the assets, being able to understand their dependencies, and then start to instrument those assets with all kinds of observable information. And that's where we'll start to see these different dashboards. One for a traditional on-prem VMware stack, and I may have ways to analyze this, and then something for the cloud environments, the public cloud environments, where a lot of these observable insights and getting to know. And then same thing with the cloud native environments, whether it is Kubernetes or OpenShift and all of those different orchestration platforms. And then as we start from that private cloud to public cloud to cloud native, going one level up, we want to understand the workload visibility as well, in terms of how a given workload, and what I have here is the observability copilot dashboard for one of the e-commerce application, where on the left side I'm tracking the service health, And I know it's a busy dashboard, but it captures a lot of data points into one single view to really present a comprehensive health of that e-commerce application, where it's tracking certain latency across the microservices, and it's tracking the overall health of the underlying resources. And similarly, we're also collating certain business metrics, like because it's an e-commerce application, and I want to track the effectiveness of transactions that are going through it. And as transactions get affected, that's what the IT ops teams care for in being responsible and accountable for the operations, for the services teams or the stakeholders. So, and then you see more metrics. One level down, you see all the infrastructure level metrics that might still affect the application availability and resiliency. And more to the bottom, you see more signals that are actually coming into OpsRamp from the same environment. We saw the assets topology, and now we are seeing logs from these cloud and cloud native environments, because these are very ephemeral and dynamic. Being able to consolidate all of those data points is important, and we are seeing how we can analyze the logs from that environments to the traces, the application traces, and being able to understand how a transaction is taking longer, a waterfall view of all of that. So being able to present all of this information and more ways to analyze this data in terms of looking at those logs and all of it. And here, this is again a more detailed view of the application performance of that workload in terms of how the different microservices are performing, the golden signals in terms of their the errors, the ops per second, and things of that sort. And more importantly, you would see for a given application, and I can click on one of those applications and go deeper into the microservices, being able to track the golden signals at the microservice level. And again, clicking on the microservice, I can go into more details of how its behavior is in terms of for the past 1 day to 3 days to past 1 week. So being able to track all of these things is one aspect of bringing the data into one place, because for the effectiveness of AI and ML, it's important we gather the data. So far we have seen how OpsRamp as a solution is bringing all of this data through native mechanisms, through the collectors and other mechanisms, integrations we have. We are getting all of this data in one place and presenting this together in terms of putting these things in a singular view and all of it. Now going back into the pipeline, I think we looked at how the discovery and observability, capturing that in one place is important. Now we'll quickly look at the actual meat in terms of, okay, now that we are gathering the data, how does AI and ML come to help in terms of analyzing all of these data signals to really provide those benefits, right? So this is where we have a lot of use cases and desire from operations team to correlate alerts and even get smarter in terms of intelligent alerting. Why only react after the alerts are received? Why can't we be proactive in even suppressing or not having those alerts in the first place? That's where intelligent alerting is needed, right? And finally, when we have these cloud and cloud native and all of these different data signals coming to us, being able to identify, okay, it's a CPU usage that caused the logs and that triggered the application latency. So being able to collapse or comprehend all of these data points gets difficult for a human driven operations. That's where again, being able to leverage machine learning to really derive that probable root cause is important. So what we will see here in this aspect is how, with all the data that OpsRamp captured, how we apply AI and ML to really derive that probable root cause, and couple of scenarios around alert correlation and intelligent alerting. Again, I'll play a little video here that actually, what I'm doing here is, I picked a e-commerce application, again deployed on microservices. It has a lot of those internal microservices running as part of the app. And then, I'll actually force a failure here where I'm purposefully shutting down, a couple of pods, or basically turning down the replica set to 0, which means it will basically turn down, the containers, and hence, one of the microservices will get affected. And what happens here is, with all of that failure that I simulated, OpsRamp captured a lot of these signals in terms of log messages and the application latency. So it said, it observed all of these aspects. It observed that the containers were deleted. It observed that the replica set was made to 0. So again, by means of our integration with the Kubernetes environments or the cloud environments, we could detect all of these different signals and present them in this view. And what happens with the machine learning being in place is, we don't have to sweat to figure out what is the root cause of all of these things. The machine learning actually did that whole thing for us, and it basically derived the synthesis of all of this, saying, the failure in the system is basically due to the deletion of pod, right? And this part, the summary that we are presenting, the probable root cause summary that we are presenting, is basically driven by the natural language processing and LLM models that we use in the background, where it basically analyzes all of these log messages, and based on the training that we have provided to it, it derives that it sees a sequence of these things, and then it presents a human readable summary of the alert issue, right? So this is where there's a lot of benefit in using LLM and NLP techniques, and not just collapsing multiple alerts, but also presenting a human readable summary of the information, right? And then, I want to show more examples in terms of certain alert scenarios, wherein I think what we are seeing here is basically how the topology that we all detected, going back into that infrastructure topology that I was showing in the beginning, with all the topology context that OpsRamp derived, it could help with the correlation of alerts when multiple things fail in the environment. And again, as we see here, there was one network switch that went down and brought together multiple KVM servers, physical servers connected to it, right? And in this example, again, we could see how OpsRamp presented a summary alert as well, collapsing all of those related alerts into one single inference. And just to highlight or bring this in context, again, I'm mapping back the topology that we discovered, right? So, we saw the KVM servers and how they are connected to one another, and we could see all these different alerts got collapsed because of the topology context the machine has in hand, right? So that's where it's important that we first have quality observable data, and then it makes it easy and effective for the AI and ML to start acting on it. Unlike, other solutions, point solutions that probably, start to act only on the alerts that they ingest from different platforms and probably don't have the context or the background. With OpsRamp, the difference is, we start from that basic foundation of ingesting data, quality observable data, and then using it as a mechanism so that when AI and ML derive something, it has a lot of confidence in saying, here is the root cause behind all of these alerts, right? Now, more examples, that we will walk through in terms of similar alert correlation scenarios. This is an example of a, infrastructure topology, but now I think, I want to switch to an application topology or dependency issue over here. And although I'm not showing all of that in the interest of time, what happened here was the application developer deployed a build on the application. And again, human misses and a lot of those configuration issues happen where they accidentally turned off one of the flag within the application code, and that triggered a lot of log messages as well as the application availability issue. And again, OpsRamp collapsed all of those alerts saying multiple log messages were detected. Error 13 is one of the code in terms of how a product catalog on the e-commerce application goes wrong and all things like that. So we basically collapsed all of those things, as well as the code deployment. As we integrate with CI/CD platforms, we could also figure out alerts that there was a code deployment that happened. We could relate that code deployment alert into all of these application issues that we are seeing, and again derive one correlated alert out of this sequence. So again, this is just a quick example of how it's not just infrastructure but also application workload driven correlation that we could drive with the AI and ML. Now moving further, I want to switch to the concept of intelligent alerting, right? I think we looked at few scenarios, how probable root cause driven by NLP and machine learning could be driven. We also looked at certain application or infrastructure topology driven data points that could help. And now I want to show a quick sample in terms of 1 second. So this is where we mean intelligent alerting, right? Again, with all the information that OpsRamp captures from the servers, because we keep track of the performance metrics over a period of time, we could basically highlight where we see anomalies in the behavior of a KPI. So this is where we can move away from the traditional conventional model of put a 70% warning threshold, 85% critical threshold, and alert me when it deviates. No, we can move away from that model and really have machine analyze the data. What is the behavior of a KPI on a system? And that could change based on seasonal patterns, based on promotional things. There could be a lot of things happening in the environment, right? And being able to analyze all of that data is humanly difficult. That's where again, if you take advantage of machine learning, we could basically detect those signals. We could highlight, okay, here is the deviation that I am seeing in a certain metric, and you could see how OpsRamp detected the general pattern of a CPU usage. This again, I'm showing an example of a CPU usage, and it actually detected the anomalies. So we could configure the system, the OpsRamp solution in such a way that we could move away from that conventional threshold model, but come up with this adaptive threshold or dynamic threshold based model wherein we alert based on anomalies that we see, rather than having to sit and configure those thresholds for each and every device and each and every metric kind of a thing, right? And then similarly, again, using the same concept of the time series data, we could, I think, so there's some lag here. So what we are seeing on the screen is, again, the anomalies that the machine identified, as well as one other interesting use case of all of this is using it towards capacity forecast and capacity planning as well. Now that we know how the system is consuming or behaving with a certain KPI, what we have done within OpsRamp is being able to apply this knowledge for certain valid use cases like storage capacity or disk capacity kind of scenarios, to really understand what is the rate of consumption of the storage or disk on a server, and being able to predict for the future, saying this will hit 95% threshold or 95% capacity in the next 30 days. So being able to alert in a predictive fashion or prepare the ops teams to forecast the capacity is one use case in how we are starting to leverage machine learning for those kind of capacity optimization situations as well. And that's what we are seeing here in terms of how OpsRamp captured, the traditional historical usage of a disk of a disk capacity, and then it forecasts what it could look like. Although it's a demo system, so you're seeing basically like a flat line, but in a real production environment, it could be an upward spike wherein it'll alert you ahead of time to really prepare for that capacity expansion for the disk, right, or storage. So these are a few. Yeah. So again, to recap, I think what we have looked so far, going back to that pipeline, the operations pipeline, we looked at the observability data, we looked at how the the machine derived few use cases in terms of analyzing that observability data and deriving a probable root cause, deriving benefits like correlating multiple alerts, as well as the intelligent alerting and forecast kind of use cases. And I think what I wanted to show next is basically the runbook automation scenario in terms of how with all of that correlation that we did, and now that we have derived a probable root cause, what else can we do with machine-driven mechanisms, right? So this is where we have capabilities in OpsRamp solution in terms of using an automation framework to act on that correlated alert and remediate those alerts, right? So this is where you could design what we call as process automation workflows in OpsRamp, and there are multiple scenarios in how we can do it. In fact, I'll probably switch to a more live environment here. 1 second. So this is the automation framework in OpsRamp where we can design these workflows to act against an alert, and you could basically design a workflow as simple as restarting a service as we see some service down alerts, or more complex scenarios that you can derive within OpsRamp. And a lot of these things are flexible enough in terms of you want to drive this automation based on the occurrence of an alert, and you have more flexible elements in place as part of this workflow execution, to really trigger something through a script or through a Ansible kind of workflows. I think it's not refreshing again. All right. So to summarize it, I think we don't just stop at using AI and ML for correlation, but also extend it for automated remediation of use cases and all of it as well. And yeah, so this is the again a live scenario from one of our customers, where before OpsRamp this was their situation in terms of when things go wrong. It takes them few hours or few minutes to troubleshoot, predict the problem, to troubleshoot, and finally remediate that. Whereas with OpsRamp AIOps, they basically started to see benefits in terms of detecting the issue. With all the correlation and probable root cause kind of benefits that I have explained, they basically got to a point where it helped them to detect and analyze the issue more quickly. And that has been the journey with that customer, and now we are working with them in terms of expanding this to leverage the automation capabilities in OpsRamp as well. So it's not just about detecting the issue, but start to leverage the automation to basically trigger a remediated scenario for those correlated alerts as well. So this will basically improve their resolution times as well. So it's not just the mean time to detect, but the mean time to resolve is the immediate outcome following this. And then there is a future desired state that we all wanted to go in terms of being able to predict the failures and even prevent them with the automation. So this is where again there's really a very good room for LLMs to be applied, the private trained LLM model that I initially described about, where this could be applied for the IT operations domain to really drive the more of predictive situation where we have mean time to availability improved for all of the business services as well. So with that, I want to wrap it up here in terms of, we are here at booth 630. So please stop by and, we can talk through more details, exchange any ideas you have around AI, ML, and how we are, doing this, and share some of our experiences around this as well. Thank you everyone for having us here.